Climatology. Climatology studies the gaseous atmosphere. Climatology is the science of climate which studies the physical state of the atmosphere over a specific region during a specific period on the basis of climate data. Climatology is compound of two Greek words, klima and logos. Klima means inclination, that is latitude. Logos meaning science of study. So, climatology is a science that seeks to describe and explain the nature of climate, why it differs from place to place, how it is related to other elements of the natural environment and human activities. So, climatology is the study of varieties of climate found on a earth and their distribution over the surface of the earth. Definition of climatology. Climatology is the science of climate which studies the physical and spatial state of the atmospheric conditions. According to Critchfield, climatology is the science that seeks to describe and explain the nature of climate, how it differs from place to place, and how it is related to man's activities. According to Austin Miller, climatology is that branch of science which discusses the average condition of the weather. According to Koppen and DeLange, climatology is a summary, a composition of weather conditions over a long period of times. According to Thornthwaite broadened the scope of climatology and suggests that it is the study of atmosphere as well as the Earth's surface. What is climate? Climate is the characteristic condition of the atmosphere near the Earth's surface at a certain place on the Earth. It refers to the sum total of weather conditions and variation over a large area for a long period of time. It is the long-term weather of that area which remains at least 30 years. What is weather? Weather refers to the state of atmosphere over an area at any point of time. The element of both weather and climate are same. It is the combination of temperature, humidity, precipitation, wind, cloudiness, and other atmospheric conditions at a specific time. Monsoon. The word monsoon is derived from the Arabic word mausim, which literally means season. Monsoon refers to the seasonal reversal in the wind direction during a year. The world is divided into a number of climatic regions. The climate of India is described as the monsoon type. This type of climate is found in South and Southeast Asia, but there are a perceptible regional variation in climate conditions within the country. Two important elements, which are temperature and precipitation, often vary from place to place and season to season. Difference in temperature. In summer, the temperature in parts of Rajasthan desert is 50 degrees Celsius and it is around 20 degrees Celsius in Pahalgaon in Jammu Kashmir. On a winter night, the temperature at Dras in Jammu Kashmir may less than minus 45 degrees Celsius, and at Thiruvananthapuram it may be of 20 degrees Celsius. In some places, temperature between day and night temperature differs. In the Thar desert, it rises to 50 degrees Celsius in day and drop down nearly 15 degrees Celsius in night. But in the Andaman and Nicobar Island or in Kerala, there is no much difference in day and night temperatures. Precipitation. Precipitation varies in its form, type, and amount and a seasonal distribution. It is in the form of snowfall in the upper part of Himalayas. It rains over the rest of the country. The annual precipitation varies from 400 cm in Meghalaya to less than 10 cm in Ladakh and western Rajasthan. Most part of the country receives rainfall from June to September, but Tamil Nadu coast gets rain during October and November. Rainfall generally decreases from east to west in the northern plain. This variation have given rise to variety in lives of people, their foods, clothes and house. Vegetation. Vegetation can affect both temperature and the precipitation pattern in an area. Factors affecting climate related to location, latitude, altitude, relief features, distance from sea, the Himalayan mountain, distribution of land and water. Related to air pressure and wind, surface pressure and wind, upper air circulation, and western cyclone.
Hours or one day. If we look at the same image of the globe, but from the top, looking down the axis from the North Pole, we see the Earth is rotating counterclockwise around the North Pole. If we look more carefully at this axis of rotation, we see that it is tilted relative to Earth's orbit around the Sun. Instead of being perpendicular, it's tilted 23.5 degrees. How long does it take the Earth to make one complete orbit around the Sun? 365 days, or 1 year. During Earth's orbit around the Sun, it follows a nearly circular path, but with a small elliptical eccentricity. The Sun is not in the center of the ellipse, but one of the focal points. Bottom line, the Earth is a little closer to the Sun every January and a little further away every July. Does that cause us to have seasons? Let's think about it. We'd expect the planet to be a bit warmer overall when we're closer to the Sun. When does that happen? January. Is that our warmest season in the Northern Hemisphere? No. So the seasons must result from something entirely different. Let's return to the tilted axis of the Earth. As the Earth orbits the Sun, it goes through 365 daily rotations, while the axis maintains its tilt. On the June 22nd solstice, the tilt causes the North Pole to face towards the Sun, while the South Pole faces away. When the Earth's orbit takes it all the way around to the December 22nd solstice, the North Pole is now tilted away from the Sun and the South Pole towards. This tilt explains why the North Pole experiences winter in January, while the South Pole is experiencing the opposite season, summer. The North Pole is facing away from the Sun and gets less overall sunlight. The South Pole is facing towards the Sun and gets more. To understand this more fully, let's look more closely at how the Sun's rays hit the Earth. First, notice that halfway in between July and January, during the September 23rd equinox, the tilt causes neither pole to face away or towards the Sun. As the Earth rotates every 24 hours, each area of Earth's surface will receive 12 hours in view of the Sun and 12 hours out of sight of the Sun. 12 hours of day, 12 hours of night. Equal lengths of day and night is why this time is called an equinox. As the Sun's rays hit the surface, they are strongest at the equator, directly in the middle, where they hit at a 90-degree angle. As Earth moves towards the December 22nd solstice, the North Pole tilts further and further away from the Sun. At its maximum tilt on solstice day, the Sun's rays are now hitting directly at 23.5 degrees south latitude, or the Tropic of Capricorn. Notice that every location within the Antarctic Circle at the South Pole is getting 24 hours of sunlight. As the Earth rotates, none of these locations is ever lacking in sunlight. This creates the summer season for the Southern Hemisphere. In the Northern Hemisphere, inside the Arctic Circle, the reverse happens. 24 hours of darkness, winter season for the North. As we watch the Earth continue its orbit, the Earth's tilt again moves towards the Sun, such that when we reach the March 22nd equinox, we once again have all parts of the planet receiving equal amounts of sunlight and darkness. The equator once again receives the direct sunlight. At high noon, the Sun would be directly overhead here. Returning back to the June 22nd solstice, we see the tilt move the North Pole towards the Sun, so that the North Pole receives more and more hours of sunlight each day. At the solstice, the Northern Hemisphere experiences summer. All points within the Arctic Circle experience 24 hours of sunlight, and the Sun is directly overhead, providing its most intense heating at the Tropic of Cancer at a location 23.5 degrees north of the equator. As we continue to watch this process, we can see that the Southern Hemisphere moves through this 1-year orbit from its winter through its spring, summer, fall, and back to winter, while the Northern Hemisphere experiences the opposite season. Note that each solstice and equinox represents opposite seasons in opposite hemispheres. The winter solstice in the Northern Hemisphere is the summer solstice in the Southern. That means that sun lovers can plan trips to maximize their sun exposure, traveling to the Southern Hemisphere in December, January, and February, and the Northern Hemisphere during June, July, and August. And if you're looking for the most intense sun on the planet, be sure to travel to the equator at the equinoxes, 23.5 degrees north in June, and 23.5 degrees south in December.
Latitude. Latitude is a distance a place lies north or south of the equator and is measured by an imaginary line called line of latitude. While moving from equator toward the pole, the temperature decreases, and in an equator the temperature is high, whereas near the pole the temperature is low. As latitude increases, the intensity of solar energy decreases. Due to curvature of the earth, the amount of solar energy varies according to latitude. In India, the Tropic of Cancer passes through the middle of the country from Rann of Kutch in the west to Mizoram in the east. Almost half of the country lies south of the Tropic of Cancer, belonging to the tropical area. All the remaining area north of the tropic lies in the subtropics. Therefore, India's climate has characteristics of tropical as well as subtropical climates. Earth's major climate zones: tropical, temperate, and polar zones. The tropical zone is between 23.5 degree north, that is the Tropic of Cancer, and 23.5 degrees south, that is the Tropic of Capricorn of the equator. The sun rays are most intense and the temperature are always warm. Tropical zone also known as torrid zone. Second, the temperate zone are between 23.5 degree and 66.5 degree north and between 23.5 degree and 66.5 degrees south of the equator. The sun rays strike earth at a smaller angle than near the equator. Third, polar zones are between 66.5 degree north and south latitudes and the poles. The sun ray strikes earth at a very small angle in the polar zones. Polar zone, which is also known as frigid zone. Highland climates. In general, highland climates are cooler and wetter than nearby area at lower elevation. Altitude. Temperature decrease from low to high altitude. Agra, which is situated at lower latitude, having high temperature as compared to Darjeeling, which is located at high altitude and having a temperature very low. Air temperature decrease with altitude. As the elevation increase, the air get cooler because of the energy drawn from the surroundings. Water bodies. Large bodies of water such as lake and oceans have an important effect on the temperature of an area because the temperature of the water body influences the temperature of air above it. Next, atmospheric circulation. Global wind are another factor that influence climate because they distribute heat and moistures around the earth. Natural processes that change climates. Solar activity. When sun is most active, it contains dark glimpses called sunspots. The formation of sunspots appears to correspond with warm periods in Europe and North America. Earth's motion. Geographic change in Earth's land and water bodies cause changes in climate. Changes in the shape of Earth orbit and the tilted of Earth on its axis are another Earth motion that affects global climate. Human impact on climate changes. The greenhouse effect. The greenhouse effect is a natural warming of the Earth's lower atmosphere and Earth's surface from solar radiation being absorbed and emitted by the atmosphere. Global warming. As a result of increased level of carbon dioxide and other greenhouse gases, global temperature have increased. This increase is called global warming. The pressure and surface winds. The pressure and wind system of any area depend on the latitude and altitude of the place. It influences the temperature and rainfall pattern. The climate and weather condition in India are governed by atmospheric conditions like pressure and surface wind, upper air circulation. India lies in the northeasterly winds region. These winds originate from the subtropical high pressure belt of the northern hemisphere. They blow south, get deflected to right due to Coriolis force, and move toward equatorial low pressure area. Air masses circulate globally. At equator, temperatures are relatively high. Land and water masses heat up, and as a result, this warms the air over them. Air heated at the equatorial region rises to the top of the atmosphere. More air rising beneath it forces the air mass to spread north and south toward the poles. Coriolis effect. The rotation of the Earth causes all moving objects in the northern hemisphere, including air masses, to deflect to the right and those in the southern hemisphere to move to the left. This Coriolis force absent in the equator. Coriolis force prevent a direct simple flow from the equator to the poles. This is also known as a Farrell's law. The pressure and surface winds in India. The pressure and wind conditions in India is unique. During winter, there is a high pressure in the northern of the Himalaya. Cold dry winds blow from this region to low pressure area over the oceans to the south. In summer, a low pressure area develops over inner Asia and in northwest India. This causes a complete reversal of the direction of winds during summer. Air moves from the high pressure area over the southern Indian Ocean in southeasterly direction, crosses the equator and turn right toward the low pressure areas over the Indian subcontinent. These are known as southwest monsoon winds. These winds blow over the warm ocean, gather moisture, and bring widespread rainfall over the mainland of India. Distance from sea. Coastal area have a equable climate, whereas as an interior part have a extreme climate. In the map we can see Chennai, Kolkata have a equable climate, whereas Delhi, Simla have a extreme climate. In Delhi it is a high temperature, where in Simla it is a low temperature. Relief. Relief to play a major role in determining the climate of a place. High mountains act as a barrier for cold or a hot winds. They may also cause precipitation if they are high enough and lie in the path of rain-bearing winds. The leeward side of a mountains remain relatively dry. Therefore, this leeward region is also known as rain shadow area. Jet stream. The upper air circulation in India is dominated by a westerly flow known as jet stream. These are a narrow belt of high altitude above 12,000 meter. Westerly winds in the troposphere. Their speed varies from about 110 km per hour in summer to about 184 km per hour in winter. Many jet streams have been identified. The most constant are the mid-latitude and the subtropical jet streams. Jet streams are located at 27° to 30° north latitude are known as subtropical westerly jet streams. Over India, these jet streams blow south of the Himalaya all throughout the years except in summer. The western cyclonic disturbance experienced in the north and northwestern part of the country are brought in by this westerly flow. In summer, the subtropical westerly jet streams move north of the Himalaya with the apparent movement of the sun. An easterly jet stream called the tropical easterly jet stream blow over peninsular India approximately over 14° north during the summer. Western disturbance. The western cyclonic disturbance are weather phenomena of the winter months brought in by westerly flow from the Mediterranean region. They usually influence the weather of the north and northwestern region of India. Tropical cyclones occur during the monsoon as well as in October November and are part of the easterly flow. These disturbances affect the coastal region of the country. Thus, very often the coast of Odisha and Andhra Pradesh are affected by those disasters. Ocean currents. Solar energy, wind, and earth rotation creates ocean currents. Current, the systematic pattern of a water movement. Gears, two great circular water motion. In northern hemisphere, the ocean current moves clockwise, and in southern hemisphere, the ocean current moves anti-clockwise. Trade wind pushes warm surface water westward at the equator. As the water encounter the continents, they split into north and south flowing currents along the eastern coast, forming north and south gears. Winds driven by uneven solar heating and earth spin drive the movement of the ocean surface current. The prime mover are the powerful westerlies and the persistent trade winds, that is easterlies. The Köppen's climate classification system. The Köppen's climate classification system uses mean, monthly, and annual values of temperature and precipitation to classifying the climates. According to the Köppen classification, the Earth can be divided into several major climatic zones and bands, such as tropical climate, subtropical climate, arid climate, equatorial climate, semi-arid climate, Mediterranean climate, temperate climate, oceanic climate, continental climate, subarctic climate, polar climate, and climate of Antarctica.
What a monsoon is. Monsoon is a periodic seasonal wind that comes from sea to land in a particular season and completely reverses back with the change in the atmospheric conditions in the next season. It is a typical yet dominant feature of the Indian climate. The term monsoon is derived from an Arabic word mausim, which means season. In olden days, the sailors found this wind convenient to set in their sails on the direction of the wind. They used to save their fuel and time by doing so. Let us discuss the causes of this seasonal reversal of wind from sea to land and land to sea. The main cause is the differential heating and cooling of land and its surrounding water bodies, that is, seas and oceans. During summer, land is hotter, and thus low pressure develops over interior parts of the large Indian landmass. Simultaneously, high pressure condition develops over the seas and oceans surrounding India. Thus, a steady flow of moisture-laden wind moves towards India and causes rainfall for almost 3 months. As the pressure system reverses due to apparent shifting of the sun from the Tropic of Cancer to the equator, the wind also reverses back to the same direction from where it comes. There is another interesting fact that the apparent movement of the sun from the Tropic of Cancer in June to the Tropic of Capricorn in December affects the global climate. The pressure belts and the wind systems change globally. The maximum effect can be noticed on the equatorial belt. Here, the northeast and southeast trade winds converge, and thus it is also called as the Intertropical Convergence Zone or ITCZ. So, due to the apparent movement of the sun, this ITCZ shifts 5 degrees north during summer and 5 degrees south during winter. The ITCZ is pushed further north till the Ganga basin due to the differential heating and cooling of the Indian landmass and its surrounding water bodies during the monsoon season. We call it as a monsoon trough. The intense low pressure system formed over the Tibetan plateau attracts air from the intense high pressure system that develops over Indian Ocean near Madagascar island of Africa. This causes a strong pull of moisture-laden air mass from ocean to the landmass of India. While the shifting of the ITCZ, the pressure system reverses, causing the reversal of wind. Around the same time, the movement of upper air circulation, or the jet streams, also affects the summer and winter monsoons of India. The global climatic events of changing pressure system over oceans have tremendous effect on the arrival, duration, amount, and retreat of monsoon in India. The equatorial belt of the tropical region of the Pacific and Indian Oceans faces the maximum effects. Usually, the situation is like when the southeastern Pacific has low pressure and high temperature. The eastern Indian Ocean has high pressure and low temperature. But the situation reverses roughly in 3 to 8 years. This reversal of temperature and pressure condition across the ocean is called as southern oscillation. Due to vast uninterrupted ocean in the southern hemisphere, The conditions are felt more than in the northern hemisphere. The normal condition brings moderate to good monsoon, whereas the reverse condition brings drought and famine to the Asian region. El Nino and La Nina are the two opposite ends of the southern oscillation or SO cycle. El Nino is the warm phase of southern oscillation, and La Nina is the cold phase of southern oscillation. These deviations from normal surface temperatures can have large scale impacts not only on ocean processes but also on global weather and climate. This climatic event is also known as ENSO. El means El Nino and So means southern oscillation. During El Nino, the monsoon will be weaker and comes late in India as summer is cooler and the surrounding sea and ocean temperature remain warmer than the usual. The Peruvian cold current is replaced by a warm current. Therefore, the pull of air from the landmass would be weak. The La Nina is good for monsoon condition as the temperature over the sea remains cooler and pressure difference between land and sea is very high. So the pulling of air mass from sea to land is very intense. El Nino and La Nina events occur on average every 2 to 7 years. The arrival of the monsoon rain in India is the most satisfying and joyous moment for the people of India. This is more because India is an agricultural country and the economic growth of each year depends on the amount and duration of monsoon rain. Delays and long breaks in monsoon rain are dangerous for the basic occupations such as farming, fishing, and forestry. This is because chances of drought and famine increase. On the other hand, a long spell of heavy rain may damage standing crops with the increased threats of flood. The secondary sector of the economy, like the agro based industry, also depends on monsoon, as the supply of their raw material is governed by a good spell of rain. The market will remain steady with a good monsoon year with stable price of food products, whereas a bad monsoon season will cause inflation, food insecurity, and public unrest. Monsoon is a unifying bond of the nature and lifestyle of India. The rivers and ponds rejuvenate with rainwater. The soil and underground water table gets support to hold moisture and water, and the parched plant and animal kingdoms become lively with the monsoon shower. The green nature of monsoon fed India has inspired poets and artists to create rich poetry and paintings that add to our rich cultural heritage.
The Indian monsoon. The climate of India is strongly influenced by monsoon winds. The sailors who came to India in historic time were one of the first to have noticed the phenomena of the monsoon. They benefited from the reversal of the wind system as they came by sailing ships at the mercy of winds. The Arab, who also came to India as a trader, named this seasonal reversal of the wind system, that is monsoon. Facts of mechanism of the monsoon. In India, the monsoons are experienced in the tropical area roughly between 20° north and 20° south. The following facts are the mechanism of the monsoons. First, the differential heating and cooling of a land and water creates low pressure on the landmass of India, while the seas around experience comparatively high pressure. Second, the shift of position of Intertropical Convergence Zone (ITCZ) in summer over Ganga Plain. This equatorial trough normally positioned about 5° north of the equator. It is also known as the monsoon trough during the monsoon season. Intertropical Convergence Zone (ITCZ). The Intertropical Convergence Zone (ITCZ) is a broad trough of low pressure in equatorial latitudes. This is where the northeast and the southeast trade winds converge. These convergence zones lies more or less parallel to equator but move north to south with the apparent movement of the sun. Third, the presence of the high pressure area east of the Madagascar, nearly at 20° south over the Indian Ocean. The intensity of this high pressure area affects the Indian monsoon. Fourth, the Tibetan plateau gets intensely heated during summer, results in strong vertical air current, and the formation of low pressure over the plateau
at about 9 km above sea level. Fifth, the movement of the westerly jet wind to the north of the Himalaya and the presence of tropical easterly jet stream over the Indian peninsula during summer. Southern oscillation. The changes in the pressure conditions over the Southern Ocean also affect the monsoons. When the tropical eastern South Pacific Ocean experience high pressure, the tropical eastern Indian Ocean experience low pressure. But sometimes there is a reversible in the pressure conditions and the eastern Pacific has low pressure in the comparison to eastern Indian Ocean. This periodic change in pressure condition is known as southern oscillation or SO. The difference in pressure over Tahiti in Pacific Ocean and Darwin in northern Australia of Indian Ocean is predicted the intensity of the monsoons. If the pressure difference were negative, it would remain mean below average and late monsoons. A feature connected with the SO is the El Nino, a warm ocean current that flows past the Peruvian coast in place of the cold Peruvian current. Every 2 to 5 years, the changes in pressure condition are connected to the El Nino. Hence, the phenomenon is referred to as ENSO, El Nino Southern Oscillation. Effect of El Nino. El Nino is a name given to the periodic development of warm ocean current along the coast of Peru as a temporary replacement of the cold Peruvian current. El Nino is a Spanish word meaning the child and refers to baby Christ. As this current starts flowing during Christmas, the presence of El Nino leads to an increase in sea surface temperature and weakening of the trade winds in the region. Beginning of the monsoon. The duration of the monsoon is between 100 to 120 days from early June to mid September. During its arrival, the normal rainfall increases suddenly and continues constantly for several days. This is known as the burst of the monsoon and can be distinguished from the pre-monsoon shower. The monsoon arrives at the southern tip of the Indian peninsula generally by the first week of June. Subsequently, it proceeds into two. First, the Arabian Sea branch and second, the Bay of Bengal branch. The Arabian Sea branch reaches Mumbai about 10 days later on approximately the 10th of June. This is a fairly rapid advance. The Bay of Bengal branch also advances rapidly and arrives in Assam in the first week of June. The lofty mountains causes the monsoon winds to deflect toward the west over a Ganga plain. By mid-June, the Arabian Sea branch of the monsoon arrives in Saurashtra, Kutch, and the central part of the country. The Arabian Sea and the Bay of Bengal branches of the monsoon merge over the northwestern part of Ganga plains. Delhi generally receives the monsoon shower from the Bay of Bengal branch by the end of June, and by the July first week, western Uttar Pradesh, Punjab, Haryana, and eastern Rajasthan experience the monsoon. By mid-July, the monsoon reaches Himachal Pradesh and the rest of the country. End of the monsoon. Withdrawal or the retreat of the monsoon is a more gradual process. The withdrawal of the monsoon begins in the northern states of India by early September. By mid-October, it withdraws completely from the northern half of the peninsula. Then it quickly withdraws from the southern half of the peninsula. By early December, the monsoon has totally withdrawn from the country. The island received the very first monsoon shower from south to north between the last week of April and the first week of May. Then it withdrew from north to south during the first week of December to the first week of January. By this time, the other part of the country is already influencing the winter monsoon. Rhythm of seasons: cold weather, hot weather, southwest monsoon, retreating monsoon. Let us discuss each of them individually. The four main seasons. The monsoon type of climate is characterized by a distinct seasonal pattern. The weather conditions greatly change from one season to the other. These changes are particularly noticeable in the interior part of the country, but the coastal areas do not experience much variation in temperature, though there is variation in rainfall pattern. In India, four main seasons can be identified. First, the cold weather season; second, the hot weather season; third, the advancing monsoon; and the fourth, the retreating monsoon with some regional variation. Cold weather season. It extends from December to February. Vertical sun rays shifted towards southern hemisphere. North India experiences intense cold, whereas the season is not well defined in South India. Light wind blows make the season pleasant in South India. Occasionally, tropical cyclone visits eastern coast in this season. The cold weather season, winter. The cold weather season begins from mid-November in northern India and stays till February. December and January are the coldest months. The temperature decreases from south to north. The average temperature of Chennai on eastern coast is between 24 degree to 25 degrees Celsius, while in the northern plain it ranges between 10 degree to 15 degrees Celsius. Days are warm and nights are cold. Frost is common in north and higher slopes of the Himalayas experiences snowfalls. During winter, the northeast trade wind blow from land to sea, so most part of the country faces a dry season. Some amount of rainfall occurs on the Tamil Nadu coast from these winds as a trade wind blow from sea to land. In northern part of the country, a favorable high pressure region develops, with light winds moving outward from this area. Influenced by the relief, this wind blows through the Ganga Valley from west and the northwest. The weather is normally marked by clear sky, low temperature and low humidity, and feeble variable winds. Characteristics of the winter season. In northern plains, there is the inflow of cyclonic disturbance from the west and the northwest. This low pressure system from the Mediterranean Sea and the Western Asia and moved into India along with westerly flow. Causes the winter rains, locally known as Mahavat, over the plains and snowfall in the mountains. Although the amount of rainfall is small, it is more important for the cultivating the rabi crops. But the peninsular region does not have a well defined cold season. There is a rare seasonal change in temperature pattern during winters due to the moderating influence of the sea. Winter. Winter is cold. Children dresses warmly to play in the snow. Animals head to their winter homes. Hot weather season. It extends from March to May. Vertical sun rays shifted toward northern hemisphere. Temperature rises gradually from south to north. Highest temperature experiences in Karnataka in March, Madhya Pradesh in April, and Rajasthan in May. Hot weather season. Due to the apparent northward movement of the sun, the global heat belt shifted northward. So from March to May, it is hot weather season in India. In March, the highest temperature is about 38 degrees Celsius in a Deccan plateau, and in April, temperature in Gujarat and Madhya Pradesh are around 42 degrees Celsius. In May, 45 degrees Celsius temperature is common in northwestern part of the country. In peninsular India, the temperature remains lower due to moderating influence of the ocean. The summer months experience a rising temperature and falling air pressure in the northern part of the country. By the end of May, an elongated low pressure area developed in the region extending from the Thar Desert in the northwest to Patna and Chota Nagpur Plateau in the east and southeast. Circulation of air begins to set in around this trough. Features of the hot weather season. An important feature of the summer season is the loo. These are strong, gusty, hot, dry winds blowing during the day, sometimes till late evening over the north and northwestern India. Direct exposure to the wind may be harmful. Dust storms are very common during May in North India. These storms bring temporary relief as they lower the temperature and may bring light rain and cool breeze. This is also the season for localized thunderstorm associated with violent wind. In West Bengal, these storms are known as Kal Baisakhi. By close of summer season, pre-monsoon showers are common especially in Kerala and Karnataka. They help in early ripening of mangoes and are often known as mango shower. Summer, long hot days. Summer fruit and vegetable are ready to be picked. You see many bees and butterfly fly flower to flower. Advancing monsoon or the rainy season. It is also known as southwest monsoon season. It extends from June to September. Intense heating in northwest India create a low pressure region. The low pressure attract the wind from the surrounding region. After having a rain for a few days, some monsoon fail to occur for one or more weeks. This is known as break in the monsoon. Advancing monsoon or the rainy season. By early June, the low pressure condition over a northern plain attract the trade winds of the southern hemisphere. These southeast trade winds originate over a warm subtropical area of the Southern Ocean. These winds are strong and blow at an average velocity of 30 km per hour. With exception of the extreme northwest, the monsoon winds cover the country in about a month. The southwest monsoon entirely changes the weather in India. The Western Ghat receives a heavy rainfall more than 250 cm. The rain shadow area like a Deccan Plateau and a part of Madhya Pradesh also receives the rain. The northeastern part of the country receives the maximum rainfall. Masiaram is the southern range of the Khasi Hill receives the highest average rainfall in the world. Rainfall in Ganga Valley decreases from east to west and Rajasthan and part of Gujarat get scanty rainfall. Breaks in rainfall. The monsoon rains takes place only for a few days at a time. They are interspersed with a rainless interval. These breaks in monsoon are related to the movement of monsoon trough. The trough and its axis keeps on moving northward or southward, which determine the spatial distribution of rainfall. Whenever the axis shifted closer to the Himalaya, widespread rain occur in mountainous catchment area of the Himalayan region, which also called floods. And the frequency and the intensity of tropical depression determines the amount and the duration of monsoon rains. This depression form at the Bay of Bengal and cross over to the mainland. The depression follow the axis of monsoon trough of low pressure. It causes heavy flood in one part and drought in other. Sometimes it disturbs the farming schedule of millions of farmers all over the country. Retreating monsoon season. It extends from October to November. Vertical sun rays started shifting toward the northern hemisphere. Low pressure region shift from northern part of India to south. Owing to condition of high temperature and humidity, the weather become rather oppressive. This is commonly known as October heat. Distribution of rainfall. A part of western coast and northeast India receives over about 400 cm of rainfall annually. But in western Rajasthan and adjoining part of Gujarat, Haryana and Punjab, it is less than 60 cm. Rainfall is equally low in the interior of the Deccan Plateau and east of the Sahyadri. Because of low precipitation found around the Leh in Jammu Kashmir, the rest of the country receives moderate rainfall. Snowfall is restricted to Himalayan region. Based on the nature of monsoon, the annual rainfall is highly variable from year to year. Variability is high in the region of low rainfall, such a part of Rajasthan, Gujarat, and leeward side of the Western Ghat. Similarly, the area of high rainfall are often affected by flood, whereas area of low rainfall are a drought-prone area. Spring. The sun shines more and the day begins to get warmer. Spring is a time when a baby animal are born. Spring is a time when plant and tree wake up after a long winter nap. Spring shower help to warm the earth, moisten the soil, helping new plants to grow. Monsoon as a unifying bond. The Himalayas protect the subcontinent from extremely cold winds from Central Asia. This enables northern India to have a uniformly high temperature when compared to other areas on the same latitude. Similarly, the peninsular plateau, under the influence of sea from three sides, had a moderate temperature. The unifying influence of a monsoon on an Indian subcontinent is quite perceptible. The seasonal alteration of the wind systems and the associated weather conditions provide a rhythmic cycle of the season. The Indian landscape and its animal and plant life, its entire agriculture calendar and the life of people, including their festives, revolve around this phenomena.